Hi, this is a presentation for climatology, EESB03. The topic we are covering is the formation of thunderstorms. My name is Sherif Nawar. My partner is
Mohammad Hansa.
A thunderstorm is merely a storm containing thunder and lightning. It is a convective storm that forms with rising air. So the birth of a thunderstorm often begins when warm, moist air rising in a conditionally unstable environment occurs. The rising air may be a parcel of air ranging in size from a large balloon to a city block, or an entire layer, or a slab of air may be lifted. The trigger or forcing mechanism needed to start air moving upward may be unequal heating of the surface, the effect of terrain, the lifting of air along shallow boundaries of converging surface winds, or when warm air rises along a frontal zone. Most thunderstorms that form in North America are short-lived, produce rain showers, gusty surface winds, thunder and lightning, and sometimes small hail. Some thunderstorms will form that may extend for hundreds of kilometers. The majority of these storms do not reach severe status. Scattered thunderstorms, sometimes called pop-up storms, that typically form on warm, humid days are often referred to as ordinary cell thunderstorms or air mass thunderstorms because they tend to form in warm, humid air away from significant weather fronts. Ordinary cell air mass thunderstorms can be considered simple storms because they rarely become severe, typically are less than a kilometer wide, and they go through a rather predictable life cycle of birth to maturity to decay, and usually take less than an hour to complete. However, under the right circumstances, more intense complex thunderstorms may form, such as a multi-cell thunderstorm and the supercell thunderstorm, a huge rotating storm that can last for hours and produce severe weather conditions, strong surface winds, large damaging hail, flash floods, and violent tornadoes. This picture depicts a supercell thunderstorm.
An ordinary cell thunderstorm tends to form in a region where there is limited wind shear and along shallow zones where surface winds converge. The first stage is known as the cumulus stage or growth stage. As a parcel of warm, humid air rises, it cools and condenses into a single cumulus cloud or a cluster of clouds. As the cloud builds, the transformation of water vapor into liquid or solid cloud particles releases large quantities of latent heat, a process that keeps the rising air inside the cloud warmer, less dense than the air surrounding it. And this causes it to grow into a towering cumulus cloud in just a few minutes. As the clouds build well above the freezing level, the cloud's particles grow larger. This also becomes heavier. Eventually, the rising air is no longer able to keep them suspended and they begin to fall. The appearance of the downdraft marks the beginning of the mature stage. The downdraft and updraft within the mature thunderstorm now constitute the cell.
During its mature stage, the thunderstorm is most intense. The top of the cloud, having reached a stable region in the atmosphere, which may be the stratosphere, begins to take on a familiar anvil shape as shown in this picture, as the upper level winds spread the cloud's icy crystals horizontally. The cloud itself may extend upward to an altitude of over 12 kilometers and be several kilometers in diameter near its base. Updrafts and downdrafts reach their greatest strength in the middle of the cloud, creating severe turbulence. Lightning and thunder are also present in the mature stage. Heavy rain and occasionally small hail fall from the cloud, and at the surface there is often a downrush of cold air with the onset of precipitation. Where the cold downdraft reaches the surface, the air spreads out horizontally in all directions. The surface boundary that separates the advancing cooler air from the surrounding warmer air is called a gust front. After the storm enters the mature stage, it begins to dissipate in about 15 to 30 minutes. The dissipating stage occurs when the updrafts weaken as the gust front moves away from the storm and no longer enhances the updrafts. At this stage, downdrafts tend to dominate throughout much of the cloud. The reason the storm does not normally last very long is that the downdrafts inside the cloud tend to cut off the storm's fuel supply by destroying the humid updrafts. This picture depicts a thunderstorm in its dissipating stage.
Thunderstorms can contain a number of cells, each in a different stage of development, that are called multi-cell thunderstorms. Such storms tend to form in a region of moderate to strong vertical wind speed shear. Notice that on the left side of this illustration, the wind speed increases rapidly with height, producing strong wind speed shear. Note that the rising updraft is capable of generating new cells that go on to become mature thunderstorms. Notice also that the precipitation inside the storm does not fall into the updraft, so the storm's fuel supply is also not cut off, and the storm's complex can survive for a long time. In a region where there is a strong vertical wind shear, both speed and direction shear, the thunderstorm may form in such a way that the outflow of cold air from the downdraft never undercuts the updraft. In such a storm, the wind shear may be so strong to create horizontal spin, which when tilted into the updraft causes it to rotate. A large, long-lasting thunderstorm with a single violently rotating updraft is called a supercell.
To end our presentation, we will show you a video of the formation of a supercell thunderstorm in time-lapse. Thank you for listening to our presentation. That's all, folks.
The end.